Welcome to part 2. In the previous video, we have used substitution to derive this result, that is indefinite interval of secant x dx equals to natural log of square root of 1 plus sin x divided by 1 minus sin x plus c. In this video, we are further going to derive some more result by modifying this result. We have that ln of square root of 1 plus sin x like this divided by 1 minus sin x here like this. Now this time what I will do is I will try to rationalize the denominator such that in the denominator I will get the differences of the squares. Therefore, to get this, what I will do is I will multiply and divide by 1 plus sin x here like this, and I will also multiply 1 plus sin x like this, okay? And did I change any meaning? No, because this one is exactly equals to 1. But by this, in the denominator form, we have a plus b, a minus b format, which can be written as the differences of the squares. But in the numerator, we have a plus b, the whole square, right? Therefore, what we can write is, we can say ln of 1 plus x like this, whole squared, divided by, in the denominator part, we can write 1 minus sine square x, right, like this, and whole root, and which can be now seen that this square and the square root will cancel, and in the denominator we can write this as cosine square x from Pythagorean identity. Therefore, by writing this and removing the squares, we will now get ln of 1 plus sine x like this divided by cosine x plus c like that. And if you see very carefully and try to split the denominator into these for each term, you will see that if you split like this, then you will get ln of 1 divided by cosine x, which is secant x, plus if you split the denominator for this, then you will get exactly tangent x plus c. And this is the standard result for our secant x dx, okay? From this to this, it nicely reduces after some modification, that is rationalizing the denominator, okay? Now from this, we knew two results. To derive some more results, exciting results, we can still modify this to give rise to some more results. Now notice that we have sine 2x, which is the double angle formula. We have 2 times of cosine x times sine x, okay? If I have the angle here, which is divided by 2, then I have to divide this angle by 2. Therefore, my sine x will now become like this, will now become 2 times of sine x by 2 like this, and cosine of x by 2, alright, x by 2 like this. And from the Pythagorean identity, we know that if we have something like sine square x by 2 plus cosine of square x by 2, and if these angle inputs are same, then it is nicely equals to 1. Therefore, what we can say is that we can modify this by using these expressions or equations, okay? Now we can see that we can write 1 plus sine x as cosine square x by 2 plus sine square x by 2, that is for 1, plus this one for sine x, okay? 2 sine x by 2 cosine of x by 2, okay? And if you observe very carefully here, this is in the form a squared plus b squared plus 2 times ab, and this can be nicely written as a plus b the whole squared. Therefore, this whole expression is just equal to cosine of x by 2 plus sine of x by 2 whole squared, right? And we also know that 1 minus of sine x is just this one sign is flipped, right? Therefore, we can say that which can be nicely written as cosine x by 2 minus sine x by 2 whole squared. Okay, now if you substitute these values here, we can say that we can here also peacefully and beautifully remove the square root. Therefore, our ln 1 plus sin x 1 divided by sin x whole root will now become ln of cosine x by 2 plus sine x by 2 divided by cosine x by 2 minus sine x by 2. Beautiful. Now for this, what I will do is I will try to multiply and divide by 1 by root of 2. Okay, like this. Inside 1 divided by root of 2, 1 divided by root of 2. Did I change the meaning of the equation by doing this? No, because if you see that it will nicely get cancelled out and it will return to the original equation. But if I multiply like this here, then what I will get is I will just get ln of cosine x by 2 times 1 over root of 2, right, plus sine of x by 2 times of 1 over root 2 divided by, in the denominator also it will be just same but minus sign in between, right? Therefore it is like this, just like this, right, plus c. Now if you observe very carefully and recollect the value, principal value for sum of the angles for cosine and sine, then we know that we have one value that is equal for sine and cosine, that is sine pi by 4 equals to cosine pi by 4, like this. Cosine pi by 4, which is cosine 45 degrees, is sine pi by 4 radian equals to 1 over root of 2 or root of 2 over root of 2. So what I will do is I will try to substitute instead of this root. Now what I will do is here I'll try to substitute some value for this root 2 by this expression such that I will modify this to some identity. Okay, so here what I will say is I will say ln of cosine x by 2 times, for this I will say sine of pi by 4, like this, and I have plus sine of x by 2 times cosine of pi by 4 divided by, for this also I will do same, that is cosine of x by 2 times, here instead of sine I will use cosine pi by 4 because root 2 is just equal. Therefore I will say cosine of pi by 4 minus sine of x by 2 times sine of pi by 4, like this. Okay, and if you see very carefully, see here, if this x by 2 be a and this pi by 4 be b, then we have cosine a sine b plus sine a cosine b, and here cosine a cosine b, sine a sine b. Therefore this whole expression is just equal to sine of pi by 4 plus x by 2, and in denominator it just equal to cosine pi by 4 plus x by 2 using the compound angle formula. Therefore this nicely reduces to, as I've said here, and if you see very carefully, we can simply write this as tangent pi by 4 plus x by 2, right? Therefore this is just equal to ln of tangent of pi by 4 plus x by 2 plus c, which will be equal to, if you use logarithmic properties, then we can express these as differences, right? Therefore we can say ln of, and this is one of the beautiful results for secant x dx. Therefore we have obtained three important results here: secant x just equal to tangent of x by 2 plus pi by 4, like this, okay, plus c. In the next video, we are going to express sine and cosine in terms of the complex function, that is by using the Euler's formula to have the result in complex sense, which is having I. Okay, so I hope you all would have enjoyed this video, and I will see you next video. Thanks for watching. Bye.